Hello everyone, welcome to Chemizon Complete Chemistry. So what is our today's topic? Logarithm rules. So now you must be thinking why being a chemistry channel, why I'm introducing you to mathematics. So it is very important in today's time to not only understand chemistry, have the knowledge of chemistry, but we must also be aware of the other uh, branches of science, that is physics, biology and basic mathematics. So we must be aware of some of the principles of other disciplines of basic sciences as well, which would be very helpful to us. So what do we mean by logarithm rules? So we are starting with a very basic topic of maths, which is logarithm rules, which is also called as log rules. So let us first understand what is the basic representation of the logarithm. So here we write logarithm as y is equal to log of x to the base a. So this is called as the logarithmic form of the statement, and there is another form which is called as the exponential form, which you can see here below, that is a raised to y is equal to x. So what are the components of this representation? So here on the left hand side you can see this is called as the exponent. What is exponent? Exponent is the power which is raised to the base. What is base? Base is this letter A, you can see here, it is the subscript of log. And x, what is x? X is nothing but the argument. What do you mean by argument? Argument is the numerical value whose log that you have to find out. So it is very simple for us to convert this logarithmic form into exponential form. This is called as the exponential form. How do you read this? It is called as y is equal to log of x to the base a, or some people read it as y is equal to log to the base a of x. So now let us understand how do you convert logarithmic form to exponential form. So here you can see ln 6x is equal to 5. Whenever you see ln, it means that the base is e. What is e? E is nothing but a numerical value. Okay, so how do you convert logarithmic form to exponential form? It's a very simple trick. What you do is, here it should be ln of base e of that of 6x is equal to 5. So what you do is, you bring this subscript of log, that is e, on the right hand side, that is the value. Okay, e, when you bring it to the right hand side, what will happen is it will push this e, this 5, as the superscript of e. As you can see here, you bring this e over here and this 5 goes on to the exponential form, as you can see here, is equal to 6x. It remains like this. So this is the trick that you can use to convert logarithmic form of the statement into a exponential form. Now how to convert exponential form into logarithmic form? You do the reverse. What you do, you add log here and you bring this e back to the subscript of log, like this, and the superscript, which was 5, will come down like this. So this is a trick in which you can convert logarithmic form to exponential form and exponential form to logarithmic form. So there are basically two types of logarithm, that is common log and natural log. What do you mean by common log? Common log is the log in which the base, okay, the base of the common log is 10 and the base of the natural log is e. So how to convert this? And very important to note that whenever there will be a base 10, we write it as log, that is in this form, log. And whenever you see this term called as ln stands for it indicates that it is natural log. That means the base would be e. So as we saw how to convert logarithmic form to exponential form, you bring this subscript to the right hand side, x would go as the exponent, as you can see here. Okay, and the n would remain as it is. So n equal to 10 raised to x. Similarly over here, e raised to x is equal to n. So now let us understand some of the basic rules of the logarithm. So log of base b of m into n can be written as log m to the base b plus log n to the base b. So this is called as a product rule, that is multiplication is equivalent to plus. Similarly, let's see the second rule where division is equivalent to negative sign or subtraction. So log to the base of b of m divided by n is equal to log of m to the base b minus log of n to the base b. Okay, this is called as a division rule. Now the rule 3 says log of base b of m raised to k. Okay, this power of the argument, this in the square bracket, in the round bracket that you can see, is nothing but called as argument, as we saw in the previous slide. So this exponent you bring here, okay, before log. This is called as a power rule. Okay, so this can be written as k into log of m to the base b. Another very important fourth rule is log of 1 is 0. Log of 1 is 0. The next rule is when the argument, that is this in the round bracket, and the base is same, then the value is 1. And the last rule is rule 6 is, suppose you bring this k over here, and then based on rule 5 you can see log of b to the base b, that is both the argument as well as the base is same. So k into 1, that value is 1, as we saw in rule 5. So this rule 6 is an application of rule 3 plus rule 5. Rule 3, as we brought this k here down, and then log of b to the base b is 1. Okay, so very important that b should be greater than 1. Why? Because any value less than -0, that is a negative value, log of a negative value cannot be defined. Okay, and m and n should be positive. That is what I said, that the argument should be negative. So this is the power rule, as we saw just now. So this is the name of this rule. This is called as a power rule. Why it is called as a power rule? So this power or exponent we brought down over here. So these are the names of the rules as we saw just now. This is called as a product rule, quotient rule. Okay, this is called as a quotient rule. This is the power rule, and this is called as a change of base rule. This is a new one. Let's see, log of x to the base a. How do we represent this? We can represent this in log of x to the base b divided by log of a to the base b. So what we did here is we changed the bases. This is called as a change of base rule. And another rule is equality rule. If the x and y, that is the two arguments, value is same, then their log values will also be same if they have the same base value. If the base value is same and the argument is also same, then the logarithmic value will also be same. So now let us understand with some examples how to convert this into exponential form. 4, you bring here, push this 3 at the exponent, it would be 4 cube is 64. Let us see another example. Similarly here you can see 5 raised to 3, that is 5 cube is 125. One more example, 7 raised to 0 is 1, and one more, that is 2, you bring here, you push this minus 3 at the exponent, 2 to the power of minus 3 is 1 by 8. Now let us see in a scientific calculator where will you find this log, that is both natural logarithm as well as the log to the base 10. So here you can see this log, this is called as a log to the base 10 or common log, and this is ln, that is natural logarithm. So you directly press this log value and put the argument value, the log value which you have to find out. Argument means the value whose log you need to find out. So log of that value, or if you want to use natural logarithm, this is the natural logarithm. So there is this concept called as log. After you have the log, if you want to convert it back into the exponential form, you take the anti-log of log. Okay, we do the reverse. That is nothing but we are taking the exponent form, we are converting it into the exponential form. So how to do that? How to take the anti-log of the value? So first you have to press this shift button, and then you can press this log if you want to calculate the anti-log of common log. And if you want to calculate the anti-log of natural logarithm, then you press this shift and ln, then that would be converted into anti-log of natural logarithm. And last very important slide is how do you convert in any equation that we will be seeing in chemistry, whether it will be in thermodynamics or chemical kinetics or any other chapter. How do you convert natural logarithm to logarithm to the base 10 and log to the base 10 to natural logarithm? How do you do that? So if you want to convert natural logarithm to logarithm to the base 10, what you do is you multiply by a factor, that is 2.303. And if you want to convert log to the base 10 to natural logarithm, how do you do that? You divide it by 2.303. So this is a very, very important slide and very important concept to be understood, which would be helpful to us in each and every aspect of all the chemistry chapters. How to convert natural log to the base 10 and log to the base 10 to natural logarithm. So here we come to the end of today's video, and thank you so much.